Consider the sum. N goes from, I'll go back to 1 to infinity, of x to the n over n. When n is 1, this is x to the first over 1. When n is 2, it's x squared over 2. When n is 3, it's x cubed over 3. When n is 4, it's x to the fourth over 4, etc. Don't forget the plus dot dot dots. And yes, you could simplify this a tiny bit. Write it like this if you prefer. This is a power series. It's not a geometric series. There's no common ratio. You'd have to multiply the first term by 1/2 x to get that term. But if you multiply that by 1/2 x, you do not get that. It's not geometric. It is a power series, though. Notice that this equals, let me use words, the harmonic series, which I'm just going to keep that in words, if x is 1. In other words, it diverges as if x is 1. And the negative of the alternating harmonic series if x is -1, which we know by the alternating series test converges. It's still a power series centered on 0. The interval of convergence is still going to be centered at 0. But evidently, 1 is not in the interval, but -1 is. The only way for such an interval to be centered on 0 is if it converges for x between -1 and 1, including -1, but not including +1. However, if we try to apply the ratio test to figure this out, the ratio test gives us no information if x is -1. If we think about our ratios for the ratio test, here is what an plus 1 is, because an is x to the n over n. Then divide by the absolute value of an. We cannot get rid of the absolute value signs completely here. With respect to the n's, we can, but not with the x's. However, it's not a big deal. That thing right there is the absolute value of x to the n times the absolute value of x. We get cancellation of the absolute value of x to the n. And this simplifies to n times the absolute value of x over n plus 1. Now let n go to infinity. Think of x as fixed. What is this approach? This approach is, it's a rational function of n where the degree of the top and the bottom are the same. They're both 1. Absolute value of x is just a coefficient, so to speak. As n goes to infinity, that's going to approach the absolute value of x over 1, the absolute value of x. For the ratio test to guarantee convergence, we want that to be true for convergence. And there's nothing to solve for. That's already in a simple form and is equivalent to saying x itself is between -1 and 1. But that's not the interval of convergence. It's almost the interval of convergence, but not exactly. The interval will contain, though, the left endpoint, because we know the alternating harmonic series converges, and therefore its negative converges as well. So the interval of convergence is a half open, half closed interval. For fun, we call it a CLOPEN interval. Get it? Closed and open. Closed over there, open over there, CLOPEN interval. For fun, make up a word. And it's still got a radius of 1 on either side, but on one side you include the endpoint and one you don't.